Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Interface Python with SQL, Part 1, Introduction, Exploring Python-MySQL Connectivity. Understanding Python Front-End Interface, Exploring Database, Back-End, Why do we use Python, Installing MySQL Connector, Establishing Connection, Creating Cursor Object with Practical Implementation for the Class 12 students of Computer Science. So, let's dive in and get started. We have already learnt about Python programming in the previous videos of Class 11 and Class 12. So what is Python programming? Python is a high-level, interpreted programming language known for its simplicity and readability. Next, we have learnt about SQL in the previous videos of Class 12. So what is SQL? SQL, Structured Query Language. SQL is a domain-specific language used for managing, querying, and manipulating relational databases. Now, in this video, we are going to learn about interface of Python with an SQL database. So, interface of Python with an SQL database means using Python code to connect an SQL database, such as MySQL, SQL Server, SQLite, etc., and perform operations on the data stored in the database tables. Python can be used in database applications. One of the most popular databases is MySQL. Python serves as a powerful tool for interacting with SQL databases, supporting operations like data retrieval, manipulation, and management. Through Python's DB API, Database Application Programming Interface, developers can seamlessly communicate with various databases, ensuring efficient data handling in application development. Python Database API supports a wide range of database servers such as Gadfly, MySQL, MySQL, PostgreSQL, Microsoft SQL Server 2000, Informix, Interbase, Oracle, Sybase, etc. Let's explore the Python and MySQL connectivity. First, you should understand about the Python front-end interface. Let's see the usage of the front-end. User interaction. Front-end interfaces in Python facilitate user interaction with the application. Graphical representation. They provide a graphical representation of the application's functionality, making it user-friendly. Input collection. Interfaces collect user input through forms, buttons, menus, etc. Output display. They display process data, results, or any other relevant information to the user. Event handling. Interfaces handle user events such as button clicks or menu selections. Validation. They often include input validation to ensure data integrity. Enhancing user experience. Front-end interfaces enhance the overall user experience of the application. Next, we explore the database, the backend. Here we use MySQL as the backend for the applications. Let's see the usage of the backend. Data storage. Databases store structured data persistently. Data retrieval. They allow retrieval of stored data based on various criteria. Data manipulation. Databases facilitate manipulation of data through querying, insertion, updating, and deletion operations. Data integrity. They enforce constraints to maintain data integrity, such as primary keys, foreign keys, and unique constraints. Scalability. Databases are designed to handle large volumes of data and support concurrent access. Security. They provide mechanisms for securing data access and ensuring confidentiality, integrity, and availability. Transactions. Databases support transactions to ensure atomicity, consistency, isolation, and durability, ACID properties. We all know that Python is a flexible, portable, easy-to-learn and modifiable language. So, we are integrating MySQL with Python interface for executing any database applications. Let's see the reasons to use Python for programming database applications. Programming in Python is more efficient and faster as compared to other languages. Python is portable. It is platform independent. Supports SQL cursors. Python takes care of the open and closed connections of the database to avoid further exceptions. Python supports relational database systems. Python database APIs, application programming interface, are compatible with various databases, so it is very easy to migrate and port database application interfaces. Our ultimate goal is to connect Python and MySQL. To do this, we need to install a connector. Let's see the step-by-step guide to install MySQL Connector and connect it with Python. Step 1. Install Python if you haven't already. Ensure that Python is installed on your system. You can download Python from the official website https://www.python.org/download/. You can check my previous video of how to download and install Python in your system. You can check the link in the description box given below. Step 2. Depending on the version of Python you have installed, open IDLE Python version XX. Here, I am opening IDLE Python 3.11, 64-bit, which I have installed in my system. Search for idle Python 3.11, 64-bit in the Start menu. Click on idle Python 3.11, 64-bit to open it. Likewise, search and click for your Python version. You can look at the image on the right side for your reference. Step 3. Navigate to Python installation directory. Depending on the version of Python you have installed, navigate to the appropriate directory. You can do this by following the default installation path or the path where you installed Python manually. For example, if you installed Python 3.11 using the default settings, you might find it in one of the following locations. When clicked on IDLE Python 3.11, 64-bit to open it. Now we enter into this screen. Now click the File menu. In the File menu, click Open. You can get into the dialog box. Here, you can see the Python file path. Just right-click and copy. And press Cancel. Go to Windows Explorer. Paste the file path. Press the Enter key. When pressed Enter key, we get into this screen. Here you can see Scripts folder. Just double-click the Scripts folder. Now we get into this screen. File path includes Scripts folder. In the Scripts folder there is a file for pip. Now, click on the address bar and type cmd, press Enter key. When pressed Enter key, you will be directed to this screen. Look at the file path now. C:/users/ your name will be displayed in your system, but here, my name is displayed 3fpra/appdata/local/program/python/python 3.11, here your version of the Python will be displayed, /scripts. Now the cursor will be blinking here. Now, we come to step 4. Install MySQL Connector /Python. Run the following command in the command prompt or terminal. Pip install MySQL Connector Python. This command will use pip, the Python package manager, to download and install MySQL Connector /Python and its dependencies. Now look at this box for detailed explanation. Pip. Pip is a package manager for Python. It's used to install and manage Python packages, which are collections of Python code and resources that provide specific functionality. Pip is the standard package manager for Python, and it simplifies the process of installing, updating, and removing Python packages. Install. The install command is one of the primary commands provided by pip. It is used to install Python packages from the Python package index, PyPI, or from other sources. When you run pip install package_name, pip downloads the specified package from PyPI by default and installs it on your system. MySQL Connector Python. MySQL Connector Python is the name of the Python package that provides the MySQL Connector /Python library. This library allows Python programs to connect to and interact with MySQL databases. It implements the MySQL client-server protocol in Python, enabling communication between Python applications and MySQL database servers. By running pip install MySQL Connector Python, you are instructing pip to download and install the MySQL Connector/Python package and its dependencies. Once the installation is complete, you can use the MySQL Connector/Python library in your Python projects to connect to MySQL databases, execute SQL queries, and perform various database operations. Now, look at the black screen. In the file path, we type pip install MySQL-Connector-Python. Now press Enter key. As I have already installed, I get the message requirement already satisfied. Otherwise we get the message, installing collected packages, MySQL-Connector-Python, successfully installed MySQL-Connector-Python 8.0.21. Step 4. Verify installation. Once the installation is complete, you can verify that MySQL Connector/Python is installed correctly by importing it in a Python script or in a Python interpreter session. Import MySQL.Connector. If there are no errors, it means the installation was successful. Now let's open the Python IDLE shell and type import MySQL.Connector and press Enter key. No errors are displayed. Note, if this page is executed with no errors, you have the MySQL.Connector module installed and ready to be used. That's it. You've successfully installed MySQL Connector/Python and connected to a MySQL database using Python. You can now start using it to perform various database operations in your Python applications. Before actually implementing SQL commands through Python interface, we can check for the MySQL client program which is running at the back end of the program. To check for MySQL user, about which sometimes we are not aware of, the following command can be executed on MySQL prompt. Look at the blue box. In the MySQL prompt, we type the statement, select current_user function semicolon. This MySQL query select current_user function retrieves the currently logged in user information. In this specific output, now, look at the yellow box. The result is displayed in a tabular format with a single column labeled current_user function. The value returned is root at localhost, which indicates that the current user logged into MySQL is root and is connecting from the local host. The root user typically has administrative privileges in MySQL and can perform administrative tasks such as creating or modifying databases, tables, and users. Let's see how to create connection. Step 5. Connect to MySQL server. Now that MySQL Connector with Python is installed, you can use it to connect to your MySQL database. All Python Database Application Interface (DBAPI) modules implement a function. Module_name connect. This is an essential function required to connect to the database, which is MySQL in our case. So we write MySQL.Connector.Connect. Here's a basic example of how to establish a connection. Now look at the green box. Import MySQL.Connector. This line imports the MySQL.Connector module, which is the MySQL Connector/Python library. It provides a Python interface for interacting with MySQL databases. To establish connection, CONN equals MySQL.Connector.Connect. Here CONN is a variable that stores the connection object returned by the MySQL.Connector.Connect function. This connection object represents the connection established between your Python program and the MySQL database server. MySQL.Connector.Connect function. This function is used to establish a connection to the MySQL server. It takes several parameters. Host, the hostname or IP address of the MySQL server. In this case, localhost indicates that the MySQL server is running on the same machine. User, the username used to authenticate with the MySQL server. Password. The password used to authenticate with the MySQL server. Database, optional, the name of the database to connect to. If provided, the connection will be set to this database upon successful connection. The MySQL.Connector.Connect function returns a connection object, CONN, that represents the connection to the MySQL server. You have to note that, replace localhost, your _username, your _password, and your _database with your MySQL server details. So, in a nutshell, this code establishes a connection to a MySQL database server running on localhost using the specified username, password, and optionally, the database name. Let's see the arguments required for connecting MySQL database with Python. Username. This is the username that you use to work with MySQL server. The default username for the MySQL database is root. Password. Password is given by the user at the time of installing the MySQL database. If you are using root, then you won't need the password. Host name. This is server name or IP address on which MySQL is running. Database name. It is the name of the database to which connectivity is to be established. Now we are creating the first program in Python script mode for establishing this connection. Open a new script file in Python, type the following script and run it. Look at the yellow box. We type the script, import MySQL.Connector. This line imports the MySQL.Connector module, which provides Python support for MySQL databases. It allows you to interact with MySQL databases using Python code. Next line, we type the script, CONN equals MySQL.Connector.Connect, open brackets, host equals localhost in double quotes comma, user equals root in double quotes comma, password, watch out the password spelling. It should be PASSWD equals Nishant in double quotes, close bracket. The password for accessing a MySQL database typically varies for each user account in the database management system. When you create a user account in MySQL, you assign a password to that account. Each user has their own unique username and password combination, which they use to authenticate themselves when connecting to the database. This line establishes a connection to the MySQL database running on the localhost server with the username root and password Nishant. The MySQL.Connector.Connect function is used to create a connection object, CONN, through which you can interact with the MySQL database. The next line holds the script, print, CONN. This line prints out the CONN object, which represents the connection to the MySQL database. Now, press the Enter key. The output indicates that the connection has been successfully established. The string representation of the CONN object shows that it is of type C MySQL connection, which is a connection object provided by the MySQL.Connector module. If the output as shown here is obtained, this signifies that the connection has been successfully established. In a nutshell, the code establishes a connection to a MySQL database using Python and prints out the connection object, confirming the successful connection. This connection can now be used to execute SQL queries and interact with the database. Now you can start querying the database using SQL statements. The following are the steps to be followed while connecting your Python program with MySQL. First, we open Python, then import the package required, import MySQL.Connector. Then, we open connection to database and create a cursor instance. Then, we execute the query and store it in result set and extract data from result set. Finally, we clean up the environment. The next step for interacting with MySQL through Python is to create a cursor object. It will let us execute all the queries we need. Thus, in order to put our new connection to use, we need to create a cursor object. It is a useful control structure of database connectivity. When we fire any data manipulation query to database, it is executed and the result set of records, is sent over the connection in one go. Although we may want to access data one row at a time, query processing cannot happen one row at a time, so cursor object helps us perform this task. The cursor object stores all the data as a temporary container of returned data and allows traversal so that we can fetch data one row at a time from cursor. So, come to the point, the cursor object in Python allows us to execute queries against a MySQL database, manage the result set, and fetch data efficiently, enabling effective interaction with the database. We need to create the object of a class called cursor that allows Python code to execute database commands in a database session. Cursors are created by the connection.cursor method. They are bound to the connection for the entire lifetime, and all the commands are executed in the context of the database session wrapped by the connection. Establishing the connection with MySQL database requires the following steps to be executed. Look at the first line. We are importing the required module. Import MySQL.Connector. This line imports the MySQL.Connector module, which is necessary for connecting to and interacting with a MySQL database from Python. Here we are using try-except block. We use a try-except block to catch any potential exceptions that might occur during the database operations. If an error occurs, it will be printed to the console. Next, we are establishing connection. Connection equals mysql.connector.connect, open brackets, host equals your underscore host, user equals your underscore username, password equals your underscore password, database equals your underscore database, close bracket. Here, we establish a connection to the MySQL database using the mysql.connector.connect method. We provide the required parameters such as host, user, password, and database to connect to the MySQL server. Next, we are creating cursor object. Cursor equals connection.cursor function. We create a cursor object using the connection.cursor method. The cursor object allows us to execute SQL queries and fetch results from the database. Next, we are executing SQL query. Query equals select star from your underscore table, cursor.execute of query. We define an SQL query as a string and then execute it using the cursor.execute method. In this example, we're selecting all columns from a table named your underscore table. Next, we are fetching results, if needed. Results equals cursor.fetchAll function. If your query retrieves data, you can use methods like fetchAll function to retrieve the results. This line is commented out in the provided code, but you can uncomment and use it as needed. Next, we are closing cursor. Cursor.close function. After executing the query and fetching results, if needed, we close the cursor using the cursor.close method. It's good practice to close the cursor after you're done with your database operations. Next, we are closing connection. Connection.close function. Finally, we close the database connection using the connection.close method. It's essential to close the connection once you're done with your database operations to free up resources and avoid potential issues. Next is the exception handling. Except MySQL.Connector error as error : print error occurred. Format of error. We use a try-except block to catch any potential exceptions that might occur during the database operations. If an error occurs, it will be printed to the console. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos, Interface Python with SQL, Part 2. Creating a database, understanding the Python-MySQL database connection program, implementing DDL commands using Python shell. You can check the link in the description box given below.